All right, we're looking at question 11 here. Now, I have two ways of solving this type of problem. I'm going to try to show both in this one video. All right, so the first way we're going to do this balancing of this equation, well, actually, we don't need to balance it. We need to find our oxidizing and reducing agents. And we are going to do one of these methods where we end up balancing it. But the other method, we're going to figure it out by just looking at our oxidation numbers. All right, so technically we're going through the oxidation numbers rules and how to determine them the same way that we introduced it in class. So I don't see anything that's all by itself. So I don't have anything that has an oxidation number of 0, but I do have some ionic compounds. So I'm able to identify the ions in there, at least on those 3 atoms. All right, and I don't have anything else that really fits there. So now we're on to our individual rules, the ones that had the variable charge. Like hydrogen was always +1 if it's with some non-metals. So I can label all these. I forgot that one. And oxygens are -2 as long as they're not part of peroxides or by themselves. So all of these oxygens are -2s. That's a +1, I forgot it. And these oxygens are -2s. Alright, but I'm actually going to go ahead and point out that all of these nitrogens are part of nitrate. So once we figured out the charge of one of them, they would be fixed. So we'll do that on this oxygen that's on the, or the nitrogen that's on the nitric acid. So I have a +1, I have 3 -2s to give me a -6. I need this to be +5 because I need 6 positives to counterbalance the 6 negatives. That means that this is also a +5, and we would find out this is also a +5. So the nitrogens don't change. All right, so I'm actually down to just a very small number of atoms that actually possibly change their oxidation states. But to be helpful, we probably would have predicted the chromate to be changing simply because it's part of a polyatomic ion and then it's not. That's a good indication that some oxidation or reduction is going on. So let's see, what is this chromium? So I have a total of -14 from that -2 and that 7. And this is going to be a total of +2. So I need a total of +12 from those chromiums. So each of those must be +6. And then the only other atom there is the carbon. So on the excuse me, on the reactant side, I have a total of -2. I have 6 positives, so +6. To get this to balance out, I would need those carbons to add up to -4. So each of these must be a -2. Actually, I'm going to put that down here. So at the bottom, I'm putting down the oxidation numbers that are changing. Over here, I have a -2. I have 4 positives. So I need these 2 carbons add up to -2. That means each of them is -1. All right, so oxidizing agent is the species that reduces. The one that reduces its oxidation number is chromium. The one that oxidizes is carbon. All right, now I said I was going to do this 2 ways, and what I'm going to do is point out that if we're very quick on figuring out what species must be getting oxidized and reduced, so we know our rules well enough. The things that are outliers, the ones that don't actually have any nice fixed rules, are oftentimes the ones that are changing. So theoretically, we would only have to have noticed that the chromium was no longer in a polyatomic ion. It was being changed, and that carbon is likely to change because the hydrogens and oxygens must have been fixed, and yet we're changing those numbers. Had we noticed that, what we could have done is just made two half reactions. And I'm going to do the chromium's half reaction. And we're going to introduce another nice little rule. Since in this case the nitrate is staying nitrate, I can kind of ignore it. And same with the potassium, because those guys have fixed rules. So what I'm going to have for my half reaction instead, I'm just going to have that chromium, chromate. And since that's with two chromiums, or two potassiums, this is a -2 ion. And I'm going to erase the nitrates on this and give myself just Cr3+. And I can't do that with the carbon and hydrogen species because that's not ionic. So I'll have to do the full thing on that half reaction. Now, technically speaking, you only have to do one half reaction. You could figure out which species being oxidized or reduced. That would make the other one have to go the other way. But we're going to do this completely. So, got the two chromiums. Now I have to balance out the oxygens by adding some waters. Balance out the hydrogens by adding some H pluses. And then I need to balance out the charge. Now on the reactant side I have the -2 and the 14 positives, give me a total of +12. The product side I have the two chromium 3 pluses, giving me a total of +6. So I need to add 6 electrons over here. Electrons as reactants, that is a reduction, therefore the chromium is the oxidizing agent. Could have answered our question by just doing that half reaction. Alright, just so we have the practice, I was going to go ahead and do the redox equation, the half reaction for the Cr2H6O. And my oxygens are fine, but I have missing hydrogens, so I need to do, and therefore to balance out the charge I need to add 2 electrons over here. That is oxidation, making the C2H6O our reducing agent. That gives us our 2 ways to solve this type of problem. Everybody finds one way easier or harder.